All right, number 13, we want to write the domain of the given function. So we have f of x equals x minus 9 divided by x minus 64. Okay, so whenever we have a rational fraction, we have to know we cannot divide by 0. So whatever makes the denominator 0, we remove it from our domain. So I'm going to start out with domain, and I'm going to say whatever's on the bottom, which is x minus 64, and then set it not equal to 0. So whatever's on the bottom, we cannot divide by 0. Start here. We're going to add 64, and so that gives us x cannot equal 64. So what that means, if I had a number line, and this goes from negative infinity to positive infinity, the number 64, let's say it's over here, would be removed. So I would have a gap in my number line. It would go from negative infinity up to 64, and it would go like right up to 64. So that'd be like 63.99999, whatever. And then we would say union. Okay, so there would be like a gap. Like imagine if there was like a hole right here, and then would jump on the other side of 64. So that would like 64.000001, however many zeros, and that would go all the way to positive infinity. So it basically takes this number line, takes out one point, which is 64. You denote that that point is not included by using parentheses, and so this would be your domain. Sometimes you can just write x is not equal to 64. However, we are asked to write it in interval notation. So interval notation is like this, and I refer to the number line to do so. I'm going to do parentheses, and I'm going to say negative infinity up to 64, and then union, and then we're going to do another set, and that's going to be 64 to positive infinity. Okay. Part B, same thing. Our expression has changed slightly. So it is x minus 9 in the numerator. The denominator is x squared minus 64 this time. So I'm going to set this expression not equal to 0 for my domain. Domain x squared minus 64 cannot be equal to 0. If I add 64, that gives me x squared cannot be equal to 64. And to get x by itself, we take the square root, plus or minus, and so we get that x cannot be equal to negative 8 or positive 8. Okay, square root of 64 is 8. So we get two values this time. So again, if I was to do a number line, let's say this is negative 8, there would be a hole there, and at positive 8, there would be a hole there. So again, negative infinity to positive infinity is the whole number line. We would go from negative infinity to negative 8, and then we would jump on the other side, negative 8 up to positive 8, and then we would go from positive 8 to infinity. So we have three partitions. When you take out two numbers, it breaks it into three groups. So part B, we're going to have all parentheses, negative infinity to negative 8, union, negative 8 to positive 8, union, 8. Sorry. Nope. Try this again. Union, 8 to positive infinity. All right, then part C, and one more part. This time we have x minus 9 divided by x squared plus 64. And again, I will start with trying to do my domain by taking the denominator setting it not equal to 0. Looks like we're kind of cut off there. And then I will subtract 64, so that will give me x squared not equal to negative 64, and then we take the square root. Okay, so the problem here, we cannot take the square root of a negative. What would happen is this would be imaginary. Square root of 64 is 8. You can still write plus or minus. But since it's imaginary, that means it's not real. So that means we're not really, there's no number that we can plug in when we square x that would give us a negative 64, because when you multiply, negative times a negative is positive. So because it's imaginary, there are no restrictions. There's not a number, not a real number that we can take out and restrict our domain. So in this case, our domain would be all real numbers, which means on the number line, there are no values that we lose. So it will be the whole number line from negative infinity to positive infinity.